So yes, part of the same group as Adam, talking about the same topic area, but looking at a different set of data. So looking particularly at spatial patterns. So the project team is quite wide, includes some geographers, some psychologists, and some data scientists, GIS people. And it's a 3-year kind of NERC funded and ESRC funded project. So this is the link. If you click on the link in the chat, then you can answer the question, how would you feel about an active shale gas site being installed near your home? If you've got a phone, modern phone, you can just scan the QR code. It should take you to a Menti page where you can answer what you feel about that. If you want, you can type in that code. So you can go to menti.com and type in that number. It should also bring it up to you. So if you could do that while I'm talking, it'd be interesting to see what people in the audience think while I'm chatting. So this talk, I'm going to talk about what fracking is. We'll look at the spatial, the Twitter dataset I'm using, how it's collected, hopefully cover some of the questions that Nick asked earlier on in the chat, look at temporal, spatial, and spatial temporal trends, and then a little bit of natural language processing, which kind of follows on from some of Nan's work there. So the background, you've heard probably, if you were in the talk earlier from Adam, about what fracking is. Just to recap, in case you weren't here, it's drilling into the ground, pumping in water and sand and chemicals, and trying to get out the gas from the shale underneath. So you're forcing cracks, which are allowing the natural gases to release. So it's known as fracking. More strictly, it's known as hydraulic fracturing. It's also known as shale gas. It's also worth noting that when you drill this hole, it doesn't only go down, it also goes horizontally, and it can do that for several kilometers. So back in 2013, David Cameron was keen on this idea of, as Adam had said, the UK emulating the success of fracking in the USA. So he said, if we don't have this technology, we'll miss a massive opportunity. But by 2019, Boris Johnson was saying it's going to be banned. More correctly, it's a moratorium. But effectively stopped doing this because of the risk of earthquakes was considered unacceptable. So this is how the UK decided to work with fracking. So they spoke to the experts, geologists, about where there potentially was actual available shale gas to be extracted. So those grey areas there are the potential blocks. And then these were available to be licensed. The yellow ones are where an actual PEDAL or a petroleum exploration and development license was available and sold. And the one that I've highlighted there, Preston New Road, is the only site where extraction has actually happened. And to give you an idea of what these things are like, this is the Preston New Road website. So you can see there's the site, and around it they have sensors. So they're very aware of the environmental impact, and they're recording noise, air quality, surface water, groundwater. And you can click on those and get the data sets for like what the noise was around that area. This is kind of what it looked like in 2000, that site in Preston New Road. And then we go through to 2018, it's developed. If you zoom in and have a look, this is how big it is. It's not a huge thing on the ground. Obviously, it goes down a long way and then can go horizontally as well. And by 2020, they're already clearing up the site. So it's been done, gone. So this project is really trying to judge what's the public attitude to this, which is why I've asked that question. So if you can have a go at filling that out, that would be really helpful. So the data sets we've used are, as Adam pointed out earlier, this Twitter data set. It's 2 different ones available in the Twitter dataset, which I'll come to the social media. We also have a longitudinal survey going on. So what that is we pay a company called YouGov, and they have a collection of participants available to answer these kind of questions. And we selected 2,777 in wave 1 because you get an attrition rate, and we're asking the same participants in waves 2 and 3. So we've done the first 2 waves, wave 3 is still to come. So these people are sent a questionnaire with a lot of detailed questions about their attitude. And we're doing those surveys about a year apart. So this project we're involved in will finish in about May next year. So that's one survey, but those people know they're being surveyed. Social media gives us free access to this kind of data of public attitude, but obviously is a very different socioeconomic group, but they don't know they're being asked. So we're surveying stuff from just their tweets. And we think it's interesting to compare these 2 data sets. So the longitudinal survey, this came out fairly recently, kind of short paper on what they found from wave 1. And in terms of the support, so about 30% supported the idea of shale gas extraction, around 55% said no, and about 10 or 12 something said they didn't know if they supported it or not. But what's interesting is the sort of overview from this research was, are there any differences in the public support across the 4 countries? And no, there's no real differences. Across the country regionally, you don't find any variation in terms of their level of support of shale gas. So that's the longitudinal study. Now, the Twitter data we're going to focus on in this talk, we have two data sets. One is the geolocated tweets, where when you tweet, you may have accidentally, or you may have on purpose, revealed your location, and that's at different degrees of accuracy we'll talk about in a second. And we've been collecting that data for 5 years. So started collecting that in 2015. We're actually still collecting it, but we decided to fix this research on 5 years. So we stopped in March 20 for the purposes of this analysis. We've also been collecting a keyword data set, which is worldwide, which is what Adam was focusing on in his talk. So that's where we have a predefined list of words. And if they occur in a tweet, we get that tweet, whether it has a geographical location attribute or not. So how do we get it? So there's a streaming API. It's free for anyone to use. We used a package called Tweepy, which is a Python library. The streaming API is free, but it only gives you a small proportion of all tweets that are sent out on Twitter. So they decide what level they're going to filter that based on how busy their servers are, and it varies. GeoTweets only make up a tiny proportion of all tweets. And from tests we've done, we actually found that pretty much all tweets sent with a location that we've tried were collected by our tool. So we believe, but it's unknown, and Twitter won't tell us, that we get most of, probably the majority of GeoTweets sent. And we set up a bounding box for the sort of UK region to collect tweets in that area. And on average, we're getting about 200,000 tweets every day captured through that API. And this means we have a PC on all the time collecting that data. And we're storing it in a Postgres database. And you can see on the left-hand side there the kind of information we get. So as well as the tweet message, we get the location lat long, from which we then transform it to a coordinate transform and put it into British National Grid and make that as a geometry. We also get the username, screen name, language, the platform they sent it from, so the source, whether it came from iPhone or Android phone, or even from another platform such as TweetDeck or something like that, the time it was sent as well. And we also get this thing which is a box. So where the information is not specifically from a GNSS device, we get a regional box associated to it from where the user account is registered. And the database, to give it some speed, with 317 million tweets, is about a terabyte of data. We've split it up amongst 3 hard disks, a solid state drive, and an NVMe solid state drive, which, if you haven't come across them, are incredibly fast and well worth the money. So we've put the tables on the big hard drive and the solid state drive, and we've put the indexes for the database and the write-ahead log into the NVMe drive. And that means Postgres can read from those 3 table spaces in parallel, as well as running queries in parallel across all CPUs. So that gives us quite a significant performance boost. So the GeoTweets are stored in 2 tables within those disks. And the reason for this is the first set of data was available, had been collecting it. The second file, tweets2, was still being collected, and building indexes on huge data takes a lot of time. So by segmenting it into 2 tables, we could statically say tweets1 is now collected, build all the indexes on it, don't have to touch it anymore. Postgres supports something called inheritance based on the idea of object programming. And so we actually do all our queries calling tweets all, and it inherits the data from tweets1 and tweets2 subtables. We build indexes, of course, spatial indexes, date indexes, including functions on the date. So we tend to do quite a lot of analysis at the day level. So by building an index on the truncated version of the created tweet date, that saves us a lot of time. We can use that index. We also have an index on the message using this gin type with a trigram ops. What that allows us to do is, when we want to filter the data for just the fracking related ones, Postgres has this I-like function, which means ignore the case, and like means it can understand these wildcards, so anything can go in here. So fracking, fracked, etc. And that will take ages to do, but it can use this gin index to do it much, much faster. So we go from, to build that index takes days, but once it's built, then we can search for stuff in seconds. And we found that if we look at fracking related tweets, out of those 317 million, there are only about 25,000. But just to kind of put this into context, if I was to read out a tweet 1 a second, 317 million would take me about 10 years. 25,000 I think would take me about 7 hours. That's reading 1 tweet a second. So still a lot of data. We had to do some tidying up. We found the Twitter API, even though we had a box around the UK, it still gives you tweets from outside the bounding box. I think that's just when they're pushed for processing, they just start feeding all sorts of tweets at you without filtering it. So do take care if you're collecting tweets to sub-filter artists. So in terms of temporal trends, we've had, let's say, this machine running for 5 years basically. And what you notice is there's some changes here, and that's where Twitter have changed their API for some reason, or they've changed the mobile app. So it used to be that when you send tweets, the location was sent with it, and then it was, if you turned it on, it stayed on, and then it's always off unless you force it on for every tweet. So the kind of location information at the GNSS or GPS level has changed over these 5 years. And they've also started, I think this increase here in 2016 is where they started packaging in location of where the user was registered in what they called a geolocated tweet. And we also had some data dropouts. That's where the server went down for a bit, or the network at university something was happening to that, and we weren't able to patch those in the first few years, but later on we had fewer of them because I moved from Stirling Uni to Heriot-Watt, so we started collecting at 2 sites and then merging the data sets. And so that's rendered about 200,000 tweets a day from 2016. So just looking at the GNSS tweets, at the beginning, you see there are loads, and then it suddenly drops off. So we know the ones that are properly accurate for GNSS, and we know the ones that are just a bounding box around sort of city level. So it dropped in terms of GNSS from about 40,000 a day down to 13,000. So let's have a look at some significant events in terms of the number of tweets sent. And here we can see something like A is where Scotland banned fracking on the right-hand side there. B is where fracking started at this site in Lancashire. And another significant one is D here, where the tremors were felt. So earthquake tremors from actual fracturing. So this one on the right just counts, just seeing where there's a lot of people tweeting. On the left, it's a percentage of all the tweets. And we get some interesting spatial patterns. So first of all, not surprisingly, you get more tweets where there are more people. So on the left-hand side, this is just a raw count of all the tweets collected. And you can see the main cities coming up pretty high. On the right-hand side, you get just the tweets relating to fracking, again, hotspots around the cities. So we need to normalize these, and we could just divide one by the other. This is 10 kilometer squares, so we've divided the country into 10 kilometer cells to do this. We could just divide one by the other, but a better technique is to do a chi-squared expectation surface. So this is adapted from work by Wortman and McCannis, who did it with Flickr data. And just take you through a simple example of how this works. So if we had 4 cells, each 10 kilometers, F is the number of fracking tweets, T is the total number of tweets. We total them up, find how many tweets there are in total in the whole map, how many fracking tweets there are. We put the chi-squared thing in, and here, the observed is the total number of tweets divided by the fracking tweets multiplied by the number of fracking tweets. And the expected is the underlying distribution of tweets, so that's just T. We can then work out for those squares what the values are, and anything around 0 is saying this is about what we'd expect. Anything negative is saying we've got less activity here than we'd expect, and anything positive is saying we're getting more activity here than we'd expect. So we did this for the whole UK, or whole GB. Anywhere that's colored green there is saying we've got more tweets related to fracking than we'd expect there to be. Anything that's gray there is saying there's a lot less tweets here related to fracking than we'd expect there to be. And on the right is just to show you again what the fracking related tweets look like. So the hotspot of London, there are a lot of tweets there to do with fracking, but compared to the number of tweets, the population of tweets that are sent from there is much lower than you expect. And if we look at the kind of spatial clustering, so what I'm doing here is looking at where we've got many green cells or many gray cells together, sorry, just the green ones, where we've got many green cells together, we basically clustered those using dbScan with a 20 kilometer epsilon. And these were the top 3 hotspots in terms of most tweets near each other, where there's a lot more activity, more people interested in tweeting about fracking than you'd expect. And the grey areas underneath are the licensed, the pedal areas. So unexpectedly, I suppose, maybe, you people are tweeting more near where there are active fracking sites. And also this group up here in Edinburgh seems to be a lot to do with anti-fracking and INEOS locations, which is one of the companies involved in fracking. Question of bots always comes up. So we had a look at, this is the number of tweets over that time period of 5 years on the top row. This is a count of all the distinct usernames where the tweets came from on the bottom row. If you divide one by the other, that gives you a rough indication of how many tweets each username sent. And throughout most of the time, it seems reasonable. There's some pretty odd things going on here. We've identified one account that's definitely odd. Whether it's a person who's very enthusiastic or a bot is unclear, but we can remove that. And I'll talk about that in a second. So this is a map of the distinct number of accounts. So again, thinking about bots and where they might be registered. So we find like the number of distinct usernames who send tweets, and then just have mapped those. And again, a lot more people here are interested in the topic of and up here in fracking than you get in the rest of the country. So in terms of spatial temporal stuff, up in the left-hand side here is the chi-squared expectation surface, but it's on a sort of moving 1 year worth of data, moving forward at 1 month steps, stepping through the data. Where it's red, you've got more tweets than you'd expect. Where it's dark green, you've got less than you expect. This map here is an attempt to squash that animation into one picture. So we're saying here, where it's orange, people have had a continued high level of interest in fracking above what we'd expect based on that chi-squared expectation surface. Where it's grey, we've had much lower continued interest than we'd expect. So it's a way of seeing that it's not just one massive spike that's caused chi-squared to show like a hot spot. It's a continued interest over that 5-year period. And this here is just looking at one particular hot topic, which was, so where you see a star is where someone's mentioned tremor or earthquake and related to fracking in their tweet message. And what we notice from about 2018 onwards, it starts to get busy. So I actually slowed down the animation here. You start to get lots of stars. And this is really the start of the downfall of fracking in the UK, and then what led to the moratorium. So lots of people were interested in this spike, which was D here, and talking about it across the country, but particularly around the area where it happened in Lancaster. Okay, so we had a look at tweet semantics, not too much in this paper. First of all, just looking at the kind of terms, hashtags people are talking about, and the kind of things that are climate emergency, ban fracking, climate change, war and plastic, that kind of thing. So these are where they've mentioned fracking and also these other hashtags. And the top mentions are things like Frack Free Lancashire, who's a group who are sort of anti-fracking, Greenpeace and so on. Jeremy Corbyn comes up as well. What's interesting is if we start to put this into a map and see across the country where we get more tweets related to certain topics and certain words coming up more than others. So in Scotland, we get mention of SNP, INEOS, Scottish Labour, Nicola Sturgeon. Over on the east side there, we get Sherwood Forest mentions, BBC York. On the left side, we get the company who are doing the fracking, which is Quadrilla, being mentioned, and Lancashire and Frack Free Lancs coming up, and Sheffield and so on. So there are spatial patterns in the kind of terms that people are talking about as well. Sentiment analysis.
Just got 3 minutes, Phil.
Yeah, it's fine. I'm almost done. So sentiment analysis, which I had a look at, it's actually really easy to do with Vader sentiment, which has been trained on Twitter data. So it understands things like punctuation, capitalization, emojis, and all that kind of thing. It also takes into account degree modifiers such as very good or extremely good, and negatives like didn't have a bad day is considered positive by it. So it does really well with that. And just some examples of the kinds of thing it does. So thank goodness fracking is banned comes out with these different scores. It gets rated on negative, neutral, and positive. It also gets a compound score, which takes into account all those. These three, negative, neutral, positive, should add up to 1. I hate fracking. I'm so glad it has been banned. It's very difficult because it has, I hate fracking, which sounds negative, but I'm so glad it's banned, which is positive. This package comes out with a negative compound. So it says the overall thing is negative. That's one of the challenges of doing sentiment analysis, where you might have multiple things in a sentence. But we tried running it for 1 year just to try this out, and the results are not particularly conclusive. This one here was because of that one account that sent lots of thousands of tweets in one time. We removed that account and we get this on the right. It's something we'll carry on investigating further. So a fairly not really a conclusive graph, I suspect, on sentiment, but there are lots of problems with analyzing sentiment. One of the other things we want to look at next is identifying names in the tweets. So you might send a message from London, but you might say Quadrilla should stop fracking in Lancashire, and you can use named entity recognition packages like Spatial in Python, and it pulls out this. It says, well, Quadrilla seems to be a company, Lancashire seems to be a place. So you could then geocode these and then look at the map, who's talking about what from different locations. So conclusions, Twitter dataset reveals there does seem to be an interest in fracking near the active sites. The spikes drop off very, very quickly. So something like the moratorium, you get a spike and then it's gone. So the Twitter community are fairly fickle, I think. It's easy to react to things and then forget about them. There's a difference between YouGov and Twitter data. I think possibly because YouGov is surveyed, they know they're being surveyed, a different population. They both reveal a sort of anti-shale feeling though across the board. And it does add some depth to understanding. We're responding in real time. We can see this temporal spatial stuff you wouldn't get from the YouGov survey. So acknowledgements to ESRC and NERC. Big thanks to GISRUK for hosting this event. And finally, I want to see how that graph is going, if anyone's voted. So we have some votes, hopefully you can see this. So most of you said no thanks, 3 said go for it, 1 said what's shale gas. Hopefully I've answered that question now. So I think you agree with pretty much the same pattern we'd see on the Twitter. Thank you very much.
Yeah, I'll just kick off with one myself. You mentioned that only a small fraction of tweets are geolocated. Have you got a sense of what proportion of tweets that is compared to the overall number?
We suspect it's around 1% or something like that, but Twitter won't say. So I guess now, this new API that Adam mentioned earlier. So what's happened is the streaming API is free. They won't publish what percentage of tweets come out of that, and they just say it's variable. But now academics can apply for it. It's a process. We have to fill out some paperwork, and they do reject people or ask you to come back. As an academic or as a MSc student or PhD student postdoc, you can apply for an academic level access to the API, which Adam and I have done. It now means you can have 10 million tweets calls a day back to 2006. In theory, we can get much more information out of that. So what would be interesting to do is compare what we've collected from the streaming API against a sample of data from that. But they've been very cagey about revealing that kind of information. So we don't actually know.
Okay. I'll just recycle a question from earlier. I just wondered how you respond to the concerns over working with this kind of social media data over data quality and representativeness, and how you respond to people who maybe raise eyebrows at that.
Yeah, so there's a huge ethical procedure to go through anytime we're dealing with Twitter data, and student projects I run deal with it. So we have to be very careful about revealing or not revealing any identity. So we make sure that all the outputs are aggregated. We make sure that we don't identify anyone individually when we're doing it. In terms of what the government do, I have no idea. Obviously, there's the Cambridge Analytica kind of things. So what their ethical views are, I don't know. If you're referring back to Bruce's question.
Okay. Nick has just come in with a question that I was just about to ask myself. I'm not down with the kids anymore. Well, I never have been really. So I'm not sure about alternative sources of social media data. What other things may be out there that you could scrape some data from to kind of bolster your analysis?
So Facebook's really difficult. When I tried using that previously, you could get to friends and friends of friends, and after that you're stuck, which I think is why we have so often those kind of questions that are like, you have to type in something and then they can access your account. But Facebook's very difficult to get it from. Instagram did make it available for a while, but then they shut it down. Twitter have been very supportive to the level of this academic API. So now they have a group which I've been involved in for a while, to sort of feeding back suggestions, and they're very responsive to it and are adding functions all the time. So I think it's really good to get involved with if you're academic, because they seem to support and recognize this is a new level of data access that we've never been able to get to before. And I think there's something that, the Googles and Apples have all this data on us as a population that we can't access as academics, nor can you if you use one of their platforms. So I think Twitter's used a lot because of the fact it is fairly easy to access compared to the other ones. There's Foursquare as well, which you can use and access data from, but different kind of data set. Yeah.
Okay, thanks for that. I'll go back to, apologies to Jeremy, he posted a question ages ago. His question is, do you have the same requests from Heriot, Watt and Sterling? If so, and apart from outages, do these produce the same outputs delivered data from Twitter? Or is there some randomness in what they filter out to send you?
It's very similar. We have a few extra ones, which I think is to do with network stuff. As I said, I think the geolocated tweets, we're getting pretty much all of them. So when we merge the data, I haven't noticed many duplicates. But I think that's just because the geolocated tweets that we're focusing for this research is already filtered down, so both sites are actually just capturing all of it. But it would be interesting to try it with the keyword things. And as I said, now we have access to the academic API anyway for Twitter, so we can access everything. Your only limitation there is the 10 million tweets per month, which sounds a lot, but when you're dealing with 300 million tweets, that's still 3 years of data collecting, unless you have lots of people helping. Yeah.
Question from Jay. Have you considered comparing the social media with traditional media sentiment, in particular the local media in the hotspots that you've identified?
Yeah, so the longitudinal survey is doing all sorts of clever stuff. I didn't mention it here, but there's also a ground-based survey. So we've got some specialists going out talking to locals, so ethnographic survey. And that's much more looking at this kind of traditional media, identifying sort of local landmarks, even if it's something like a bush that becomes a meeting place, how important that is and how, what's going to happen to the community if something is destroyed, all sorts of long conversations and the kind of open-ended questions where you can only have it in a discussion. So that work's all going on. Part of this project is because a big group of people, we have these 3 distinct data sets, 2 kind of spatial ones, which is the longitudinal survey and the Twitter data, this other ethnographic survey. And we've now got a new person who's joining the group, Colin, who's going to be, his job is to look at synthesized papers where they take all 3 elements and bring them together. So we've not really got to that bit yet of how we can compare social media with traditional media so much, but we will be getting there. And one of the kind of key things, I think, of this project is to see, like the discussion that goes on with the census. Can we get away with the traditional census and just use online instead? So in many ways, could we just use Twitter to see what the population is, or is it different? And I think we already answered that, it's different. So how we come to any conclusions is difficult, but it's just showing that every survey you do has some kind of different audience or different participants and different socioeconomic backgrounds, etc. We have to take that into account. But good question. We are looking at that. Haven't done it yet.
Sure. Thanks for that. And I think that answers Caitlin's question as well, who was talking about qualitative research.